if I have x, what the heck going on here? If I have x plus a, that looks like a 9, a, and x minus a, I get x squared minus a squared, right? The linear term drops out. Everyone knows this, yeah? Okay. This is what we call a conjugate. So let's look at our situation here. What is different in number 1 than what we were doing yesterday? There's now a binomial denominator, yes? And both parts of that we hate, right? So we know that we can get rid of root 15 by multiplying by root 15, yes? And we know we have to multiply by 1, so we got to put a root 15 up there, right? But we got to get rid of 2 of these things. Now, in yesterday's work, no problem. We just distributed because we only ever had 1 on the bottom. But now we got 2. But we've got to use the conjugate because we need the radical to disappear. And here is what I mean. If I did x plus a and x plus a, I end up with x squared plus 2a plus a squared, yes? Right? Now, notice that 2a right there. Well, in this case, if this was a minus, that 2a would have radicals in it, wouldn't it? Everybody understands this? You can follow this distribution pattern? Hello, Jose. If this was a root of a and a root of a, this would be 2 root a, wouldn't it? And we don't want any radicals in the denominator, do we? So we have to remember conjugate. What is the conjugate? It is the same binomial with the opposite operation. So this is negative, so we use a positive. If this was positive, we'd use a negative, right? And then it's just grade 10 FOIL, okay? Now, I, of course, am going to write it all out. You all know that root 15 times root 15 is 15, yes? But I am going to do my due diligence and write it all out. It's going to take up the whole space. You're not going to need that much space, but we're going to write it all out. So this top one up here is going to be the root of 7 times 15 plus the root of 7 times 10. That is the top section. Is there anybody that doesn't understand what I did there or doesn't remember how to do it or whatever? We're all cool there, right? Okay. Over. And now this is where it gets tricky. 15 times 15, so root of 15 times 15. Right? And now I'm going to write it all, even though you know you don't need it. Plus root 15 times 10, right here, minus root 15 times 10, right here, and then minus root 10 times 10. Now I tidy it up. Root. Now, stop for a second. You know we're going to need to simplify, yes? So right here, I'm already partially simplified, right? What's going to happen to that 15? 3 and 5. Any pairs? So that's not going to change, is it? So I'm stuck with root 105. Plus, what's going to happen to this 10? 2 and 5. Any pairs? So I'm sticking with root 70 over square root of 225 gone minus the square root of 100. And then we just finish off. Root 105 plus root 70 over 15 minus 10, which is root 105. I'm going to run out of room. Root 105 plus root 70 over 5. And we're done. Everybody cool? The only difference is we've got to remember how to do double distribution down here. But you can all see the shortcut already, can't you? It's just 15 minus 10. That's what we ended up with, right? 15 minus 10, 15 minus 10. Everybody cool? Okay, the key to remember is it has to be the conjugate. Now, there are some wrinkles to this. And the very first sample here has one of those wrinkles. So the first thing I'm going to do is I'm going to rewrite the word conjugate, because every year I give an instruction on your first quiz on this that says use the conjugate, and every year the whole class says you've never taught us that word ever. Unfortunately for most of you, you were in my Honors 10 class where I taught you how to do this. Actually, no, I don't think I did. I think we only did we did binomials as well? Okay. So you all know this word. And if you weren't in my Honors 10 class, you've seen it today already, and I've said it like 18 times. So don't give me any of that horse crap. And it's been recorded for posterity. In 10,000 years, somebody will unearth some Google server from the bottom of some valley in Palo Alto, and it will have my videos on it. And they will be like, oh, he was a mad prophet of the airwaves. But no, they won't. But only 235 people ever listened to anything he had to say. Anyways, remember, if this is what you're dealing with, this is your conjugate. Now, doesn't matter what's up top. So we don't care about the top. What do I need to get rid of over on this side? No, what do I need to get rid of, McKenna? What's the thing that bothers me on the left? Just the root 3, right? So if I multiply by root 3 over root 3, again, we don't care about the numerator, I end up with 2 root 9, yes? And that root will disappear. Could I multiply, if I wanted to, by 2 root 3? Would that still get the radical to disappear? But then I have 4 root 9, and I have the possibility of more simplification later on, right? Okay. Come over to here. What's the thing that bothers us? Just the root 3, right? Okay. So if I multiply by root 3, that's going to get rid of that root 3, isn't it? But what's it going to give me right here when I hit that? Another root, right? Okay, so, okay, Byers, yeah, here, now you're not fooling me. We got to use that word that you never teach us. We got to use the conjugate. So what's got to go here, a plus or a minus? And then 2. Will that work? Let's check. What's 2 times root 3? Or 2 root 3 times root 3? 2 root 9, right? Okay, and then minus, what's going to happen here? When I go from there to there, what am I going to get? Minus 4 root 3, right? And then what is going to happen when I go there to there? I'm going to get plus 2 root 3. What's going to happen when I combine those like terms? Negative 2. What? Root 3. What am I trying to get rid of? Root 3. So remember, when we're doing a monomial, We only need to worry about the root 3. We don't need to worry about the coefficient. But here, if we forget the coefficient, what happens? We don't get what we want. So we got to remember, the conjugate includes coefficients. Because if we don't include the coefficient, this barfy thing happens. Okay? Because remember, it's got to be the exact same thing to make the middle term drop out. Just like in regular polynomials. Yeah? Okay. So let's look at letter B there. Or as your elementary school teachers always said, number B. I don't know why. This is still a thing? Did your elementary teachers say that? You don't remember? Elementary school was like 4 years ago. You people remember 4 years ago. You never had a teacher say number B? It wasn't 6 years ago. Oh, you're in grade 11. All right, yeah, I suppose. And then elementary school here is grade 5, isn't it? Oh, yeah. Okay, I'll allow it. Of course, that means that when you're 45, you will not remember anything that happened to you before you were 40. If you can only remember 5 years in your past. But whatever. I'll come to your 10-year reunion. You'll be like, who the hell are you? Never seen you before in my life. Why are you so loud? You're obnoxious. Go away. Not one of you jumping to my defense and saying, no, Mr. Myers, we would never say that to you? Well, okay. Gotta make a cahoot. Do I know my class? My class is full of mean, horrible people. All of the above. What's the conjugate here? 2 root 3 minus root 2. 2 root 3 minus root 2. Now, ladies and gentlemen, you can see how involved this is going to get, yes? So again, I stress, until you're super comfy with it, I really stress writing it all out. So this first one here, and I'll do that one in black, I am going to actually write 3 times 2 root 2 times 3. Do you have to? No. If you're comfortable, go ahead. But when it gets really complex, don't come to me, oh, Mr. Myers, I'm 20 steps in and I don't know what's going on. All right? Then the next one is going to be what? No. Negative 3 root 2 times 2, because we're doing FOIL. And then plus what? 2 root 3 times 3, and then minus root 2 times 3. Now for this question, on the bottom, I'm going to write it out properly, right? Except I am going to do a little cheat on the bottom. Because we've got the conjugate, what do we know is going to happen? Do I need to do the OI of oil? FOIL. Do I need to do the OI? If I gave you x plus a, x minus a, do you need to do the OI? No, because it's going to drop out. So you only need to do the f and the ol, right? No OI. So over here, do I need to worry about 2 root 3 times root 2? No, because that's part of the OI. Wait, no, that's the first. No, that's the OI. That's the outsides. I don't need the OI. All I need is 2 times 2 root 3 times 3, plus or minus here. minus root 2 times 2. Because I know the middle term is going to drop out because I've done grade 10 polynomials. Yeah? Now, I know that's big and ugly, and I know all of you have some sort of allergy to showing work. It makes you break out in hives, and you have to breathe funny, and you got to go get an inhaler, and I got to call 911. I know you have this allergy to showing work, and you all seem to think, every single one of you says, oh, Mr. Myers, I'm so bad at math, but then you try to do everything in your head. I don't understand that dichotomy, but that's what all of you do to me all the time. I'm so bad at math. Show your work. What? No, I can do that in my head. But you just told me you were, oh no, I'm awesome at that part of math. Whatever. So, what am I going to get here? 6 root 9 plus 3 root 4 plus 2 root 9 minus root 6 over 4 root 9 minus root 4. Now I tidy it up. What's the root of 9? So, what? Oh, that's a 6. Thank you. So, tidy up everywhere I can. Can I tidy up there with anything? Right there. What is 6 root 6's take away 1 root 6? 5 root 6. Gone, gone. Can I do anything here? What's the square root of 4? Times 3. What's the square root of 9? Times 2. So I got 6 and 6, don't I? Which is what? Over. What do I got here? What?
We have a question. Shouldn't plus 3 root 4 be negative?
Plus 3 root 4. Okay. So it's negative 6 plus 6. So it's gone, right? So 5 root 6. And then what? $12 minus. So what do I get? Then what? Root 6 over 2. And we're all cool, right? Everybody good? Everybody good? Okay. Now, normally, what would I suggest you do with that 12 right now at the beginning? I would suggest you would simplify it, right? But does that make much sense to simplify it now? You know that you're going to do, what are you going to multiply here? It's going to be your conjugate, yeah? Which is what? 3 root 12 plus 4 root 3 over 3 root 12 plus 4 root 3. All these numbers are fairly small. The only big number is the 12, yeah? And you're going to hit 12 and 12, so what's going to happen to 12 and 12? They're going to disappear anyway. It's going to be 12, right? Now up top, yeah, you're going to get a root 24, but that's still pretty easy to simplify, right? Who makes this decision? You do. Don't, what's the word I'm looking for? Forget I just said the word don't. Look at each question and make your decision, okay? 12 is not that big. Maybe you don't want to simplify 12 right now, right? Because the biggest thing you're going to be doing is doing 12 by 2, okay? Now, what if this was something like 18? Would you then consider simplifying the 12 and the 18? Probably. But you make that decision, okay? So in this one, I wouldn't simplify the 12 yet because I know my biggest multiplication is 12 times 12 and it's going to drop out, right? Okay. Who wants to attempt this with a little less work? I hope all of you by now. What is the numerator going to be? There's the first one. What's it going to be? 6 root 24 plus, what's the next one going to be? 8 root 6. Everybody can do that in their head, yeah? Now, on the bottom, this is where you may want to consider writing because you've got all kinds of coefficients, yes? But maybe you don't need to because what are you going to do with the 3 and the 3? No. You're going to multiply it, just like we did over here. So what am I going to get there? 9 times 12, right? So, do I need to write that there for one more example? This is going to be 9 root 144. So I went one step past here, right? Where I went 2 and 2 and 3 and 3. So I'm going to do that. And then I know the middle's dropping out. So then I'm going to get 16 root 9. Yes? Right? 4 and 4, 3 and 3. And now I'm going to tidy it up. Does 24 tidy up? To what? 4 and 6. I'm bringing out the 2. 12 root 6 plus 8 root 6 over... What is the root of 144? Times 9? 108. Exactly. 108 minus, what is the root of 16? Or the root of 9? Times 16? 48. 12 root 6 plus 8 root 6 is what? 20 root 6s over 60. Am I going to tidy that up at all? To what? Root 6 over 3. Are we all good? Now, it doesn't get any more difficult. Just the numbers get bigger. So you may need to simplify a few times. All right? But you can see how busy it can get. Right? So you all look closely at D right now. Because we are going to do page up to F on page 47. Then I'm going to shut up. Look at D and tell me what's different. There's an X in the variable, yes? Right? But does that change anything? Of course not. So what is my conjugate here? Root 4x minus 1. Root 4x minus 1. Then I just go ahead and work on it. What's the top? 6 root 4x. 6 over root 16x squared, or because we know that the root of x times the root of x is just x, what can I write here? 4x, then what? Negative 1. And then is there any tidying up I can do there? I can bring out the 4 to get 12 root x minus 6 over 4x minus 1. Right? Now there is one more thing I could do there, and that would be factor. But you can see my third unit is factoring. Right now I care about tidying up the radicals. Right? But you can see we're at the very end of a unit, yeah? So I'm starting to kind of inch in with some of the next unit stuff. What would you really do there? Of course, you would deal with that 12 and that 6 because there's a GCF there, yes? But right now I'm cool. Everybody good? How is E different? It's all under the radical, yes? So what do I need a conjugate here? This is tricky. What am I going to multiply by? Nanru? That's your guess? So you would put negative root 4x plus 1? I'm just asking you, yes or no. That is your guess. Okay. Henry? You're just going to square it, right? Because that's going to make whatever's under there disappear. Because, again, that's going to get me the square root of 16x squared plus 1, right? What is the square root of 16x squared plus 1? 4x plus 1. So, tidy it up. I got 6 root 4x plus 1 over 4x plus 1. And would I stop there? You can make one change. Can you do the 6 and 4 divided by 2? Why not? Because that's a 4x. Am I done there? You feel I could take the 2 out of there? So you're saying this would be 12 root x plus 1. Yeah? Nothing else you could take out of there? Why could I take the 1 out? What is this really? Is this the root of x plus the root of 1? Is it? So what's the root of 1? So what's this? 13? Just 12 root x? That's what we're going with? Is that next unit stuff? Is that factoring stuff that we're talking about? Are we getting down to really nitty-gritty details? What's the goal of this unit? What's the goal of this lesson of this unit? To tidy up the denominators, right? Is our denominator tidied up there? Are we okay? Would I be happy? Okay. At this level, do I care about nitpicking down to the last detail of every question? Who's going to nitpick down to the last detail of every question? Future people, right? I bring concepts to you. I let you fine-tune them as you go further. Everybody good? All right. What's weird about F? Because this is the last one we're going to do together. Then I'm shutting up. There's a fraction. Is that fraction completely encased by the radical sign? So how could I rewrite that? 6 root 4y over 6 root 12? Just root 12, right? Because that 6 is over 1, yeah? Okay. You want to tidy any of that up, or do you want to just deal with the radical now? You want to tidy up now? Okay. So, what's that going to give me up top? 12 root y over what? Two root 3. Now what bothers us? So what am I multiplying by? To get what? 12 root 3y over what? 6. Now what am I tidying up? Two root 3y. Anything coming out of that? Everybody good? Yeah? Okay. 47, 48. Wow, that's a lot. 47 through 50. But I'm giving you a lot of time right now. Now, you will notice that 51 says radical assignment. Yes? It doesn't have the chocolate dream font? More Morse code font. I'm going to say that, page 51, we're going to do tomorrow with our quiz. Okay? So 51 is in class tomorrow with quiz. Aight? Go. There's the bottom of 47. Check. Did you do it right? A great many of you that I saw left that like that. That doesn't really bother me too much, but we don't really like a negative, or we don't really like 1 as a denominator. So you got to put the negative out in front. And it makes the whole thing negative. I would also accept negative 3 root 2 minus 3 root 3. But of course, the best answer has the negative out front because we don't like leading with a negative. We would factor it out. Anybody want to ask about D and E on 47? And all this work was recorded, by the way. It's being added on to the end of the video. Both of those are the same thing. did that in my head. Just let me make sure. Everybody good with the top two on 48? They're the same thing. They're the exact same thing. Are people ready to see A and B? A only? Now, once again, ladies and gentlemen, what I'm doing here is 4 times 4 times 4 times 5, because root 5 times root 5 is 5, minus 3 times 3 times 2, which gets me 80 minus 18, which is 62. Right? Everybody understands that, yeah? Now I go up to the top, and I get 20 root 40 plus 15 root 16 minus 24 root 25 minus 18 root 10. And then I simplify. That is 40 root 10 plus 60 minus 24 times 5 is 120 and minus 18 root 10. 40 minus 18 is 22 root 10. 60 minus 120 is negative 60, and I'm all over 62. What goes into 22, 62, and 60? 2. 11 root 10 minus 30 over 31. Okay, now McKenna, you did all the right stuff, but somewhere something happened because you had 60 on the bottom. Okay. Because 3 times 3, yeah, because you did 9 times 4. When you did the root 2 times root 2, you left a 4 there, right? Now, again, is that a 0 out of 4 for me? You did everything else right. So what am I giving you? Probably a 2.5, 3 out of 4, right? Everybody good? Satcho. Well, no, this is the simplified one. Yeah, but this is the simplified one. You would not leave me this. All right, now, ladies and gentlemen, a lot of you looked at this and were a little freaked out, right? This is the same as 2 root 2 minus 4 root 3 over root 75 minus root 50. Now it's got an order that you're comfortable with, right? Still got a positive 75, still got a negative root 50, right? Now the conjugate is easy to do. But of course, you may want to consider simplifying so you don't have these big giant numbers up top, 75 times 3, 50 times 3. You may want to simplify first. So you may want to go 2 root 2 minus 4 root 3 over 5 root 3 minus minus 5 root 2. And now it's easier to work with. Of course, that makes your conjugate 5 root 3 plus 5 root 2, 5 root 3 plus 5 root 2, and then I just go to town. That is 10 root 6. That one. Now, ladies and gentlemen, I can't stress this enough. I know that you feel I'm going to use the word immature because that's the only reason I can think for not doing what I'm about to do. For some reason, you all have this real hatred of actually doing distribution. You think you can keep it all in your head. How is that working out for you most of the time? Not very well. And yet, you continue to do so. Right? Does that make any kind of sense? To me, it just doesn't. Right? Even I make mental math errors, don't I? You catch me because there are 30 eyes watching me waiting for me to F it up, right? Because I know you are. You're sitting there, oh yeah, that's -6. I know that's what you're doing. I wish you would pay that much attention to your work so you wouldn't make those same mistakes that I make. Because I am making mental math errors because I am having to keep this running commentary going all the time while in the background my brain is doing the math. Okay? Don't give yourself problems. Okay? Actually do the arrows and then you can't screw it up. The next one is 10 root 4. The next one is minus 20 root 9. And then minus 20 root 6. All over. Now down here I don't have to worry because I'm just doing the f and the o, which is 25 root 9 minus 25 root 4. Then I tidy up. 10 root 6 minus 20 root 6, well, that's easy. Negative 10 root 6. 10 times the root of 4, which is 2, that's 20. 20 times 9, which is the root of 3, is minus 60, so that's minus 40. Over 25 times 3 is 75. Minus 25 times 2 is 50. And then negative 10 root 6 minus 40 over 25. What goes into 10, 25, and 40? 5. Negative 2 root 6 minus 8 over 5. And again, you may get future teachers that want that negative out of there. But I do not wish to pile detail upon you. If you can get to there, you're just fine for now. But I cannot stress this enough. You guys haven't been drilled with math the way we were drilled with math because somebody decided it was a bad way to teach math. I personally disagree, but I am only one dude. Okay? Other people think that memorizing stuff was bad, evil, blah. But of course, you will notice, do I ever approach a question scared? No. Why? Because I have all my math stuff ready to go. I am not wasting any brain power on this multiplication. Because my multiplication is memorized and ready to go. I am thinking about radicals only. You guys, and it's not your fault, you have not been drilled. And what I mean by drilled is when I was in grade 8, teacher started the class with a 50 question worksheet on one topic. But that's looked upon as bad teaching now. But you will notice that all us old people aren't scared of math, are we? We are not going to get to the last page 48. Page 48, 49, and 50 is what you were working on tonight. Tomorrow is all work day. Answers to this, quiz, radicals assignment, which is your review for the unit. All right? 50. Tomorrow we'll do 51 and 52, Sal.